This video will give you a couple of examples of Euclidean distance. What we're looking at in this map is a county, Fingal County, in Ireland. It's just north of Dublin City. And we have two layers of data, well, three layers of data. We have the yellow polygons that are the counties. We have these green dots that are local playgrounds. And we have these sort of heavy brownish lines that are the bus routes. So we could compute, say, Euclidean distance to playground or Euclidean distance to bus route. I'm going to start with the playgrounds. And before we really get underway, I would like to have a separate layer that is just Fingal County, not all of the counties of Ireland. So I will select it and right-click Data Export and make myself a polygon that is just Fingal. And I can remove this one and make sure I have cleared all selected features. All right, this just is going to make some things that we do later easier. So let's start by just running Euclidean distance to playground. We go into the analysis ribbon, get the toolbox, find spatial analyst tools, and under spatial analyst tools, Euclidean distance lives in the distance tool set. Here's the Euclidean distance tool. It's actually a really easy tool to run. The only thing that goes into it is a set of origins. Those origins can be points or lines or polygons like these playgrounds are points, or it could even be a raster, and we can learn more about that in class. But let's put in the playgrounds as our origin point. And I just don't like their default name here. I'm going to call it distance to playground, because at each point you will see the distance to the nearest playground. And the first time we run this tool, I'm going to recommend we take all the defaults. The cell size we will be able to change, but generally the tool decides what a reasonable cell size is. You can go coarser, you can put a bigger cell size in here so that you get a more blocky output, but if you go finer, too much finer, it will tend to crash the tool. The other thing I want to point out before I run the tool is these numbers that are scrolling at the bottom of the display. They are large numbers, so they are in meters. We are doing this project in a distance-based, meters-based Ireland projected coordinate system, which is a good coordinate system to be running distance in. So leaving everything the same, let's run the tool and see what the output looks like. All right, well, the output showed up behind the county. Here, let's move it on top of the county. All right. This is the default symbology you get from the Euclidean distance tool. It is a raster, and it is being displayed in a classified raster symbology. So, you know, there are hard breaks between the classes. This dark green means very close to a playground, then sort of close, then maybe close to a playground. Now we're getting a little far from a playground, you know, really far from a playground. It's not the most attractive symbology. And the other thing that you'll notice is that it doesn't quite cover all of Fingal County. Let's deal with those things one at a time. First, let's just change the symbology to something a little more attractive. As you see, it comes up as a classified symbology. We can change it to stretched, and that's maybe a little severe. Maybe we could do like some nice blue colors. And, oh, that's very pretty with the little white starburst in the upper corner there, but it doesn't really tell us about distance close to our playgrounds. So we could change the stretch here to something that shows us a little more contrast. So now in this image, The dark areas are very close, and then you have a gentle gradation of color as you get further away from the playgrounds. That's a nice symbology. I like that. But it doesn't solve the problem of we still didn't quite catch all these areas of Fingal County. The reason for that is the default extent of the output is the minimum extent of the points that went into it. So if you drew a box that was the smallest box that could contain these points, and I know some of them look like they're not contained, it's just because I used big symbols, but the output is the smallest box that contains those points. We could change that extent to be the extent of Fingal County, and then we get a slightly bigger output that might look a little bit better. So we can do that by using the History tab and just running the exact same tool again with all the same settings. This little exclamation mark means it will write over distance to playground. And click Environment at the top. The Environment tab allows you to set things that are normally done as defaults. You could change the output coordinate system instead of using the coordinate system of the map, for example. You could change the cell size if you wanted to. And one of the things you can change is the extent. If you pull down this tab, you find that you can use the extent of any one of our layers or some combination of them, a union, an intersection, etc. I'm going to use the extent of Fingal. That's the smallest rectangle that contains all of Fingal County. It fills in these numbers here. That's just the extent of Fingal. And then if I run it, we'll probably go back to the default symbology. Let's see. Yes, we do. But at least it's the default symbology that covers all of Fingal County. We could make Fingal, for example, hollow and, see it on top here. Let's try that. Okay, that's not bad. But we could clip this raster so that all that we saw was the raster inside of Fingal County. Raster clip, let me close symbology temporarily. Raster clip is in our toolbox. It is a different clip from the clip we've been using for vectors. It lives under data management. Then way down here, there's a raster tool set. And this is under raster processing. It's called clip raster. The ingredients are just about the same as what goes into a vector clip. You first put in the thing that's too big, the raster. Then, for output extent, you put in the thing you want to clip it to. We'll say the outline of Fingal County. If you don't check this box, your output will be a rectangle. That is the minimum box that represents the extent of Fingal County. That's what we have right now. If you check this box, you will clip to exactly the boundaries of Fingal County. Fingal County will be used as a cookie cutter. And so if we run that, we get a new raster. I turned off the old distance to playground. And maybe I'll again change the symbology just to make it a little easier to see. If we use that blue again, that was nice. And I think I use histogram equalize. There, that's kind of attractive. Now, just within Fingal County, you can see all of the land colored by distance to one of these playground points. Now, you might ask, and I'm asking, what are the values in this raster? Let me turn off the outline so I only get one value. We're getting a value of 0.088. And here we have a value of 0.046. And here we have a value of 0.00 something. I suspect the values we're seeing here are decimal degrees. It's possible that if we had set the coordinate system when we ran this, we might have been able to get the output in meters. But before I go try that, let's, just as a second example, let's do the distance to the buses now. So I'm going to turn off the distance to the playground. I'm going to turn off the playgrounds. And I'll put on the bus routes. Now again, I think I've said this before, when you have your bus routes clipped to a county, you are missing bus routes that are off the bottom of the map, for example, or off this side. But right now we're only concerned about distance to a bus for the people who actually live inside Fingal County. So we'll do the tool again. We'll run, geoprocessing. We can close all of this data management toolbox that I had open before. Go to Spatial Analyst. Go to the Distance Tools. Run Euclidean Distance on the bus routes. Call this distance to bus. And I'll change my environment. Let me see while I'm in here. Maybe I can change the coordinate system to that of the current map, which is Ireland Transverse Mercator. And I'll make the extent of Fingal. And maybe we can get our answers in meters now. Let's try that. So the first thing to notice is the lousy symbology. But if we click on that, let me go back to the view of the whole county. Let me turn off the county so I don't pick it up every time I use the identifier. And let me just get the values in some of these pixels. 2,506, 5,747, come in really close here. 795, can we get any closer? 281, these really are probably meters now. I think by changing the coordinate system that the tool ran in, we got our output in meters. And again, I could clip this. So tools, go up to data management. Find raster, clip raster. We're going to clip down the distance to bus. We're going to clip it to the shape of Fingal. We are going to use Fingal as a clipping geometry. Okay. I'll turn off the classified distance to bus and change the symbology on this layer. And maybe I won't use blue again so we don't get confused. Let's use, oh, I bet this is going to be pretty. Ooh, that's kind of nice, but I feel like it's backwards. If I click on this and go to Format Color Scheme, this little sailboat over here allows you to change the ends of your color ramp so that the lighter areas indicate the closer to the buses and the darker areas indicate further away from the buses. So we can just take a moment, and if I remove the bus routes, and zoom back out a little bit, we can really get a sense of the rasters by themselves. So here is the distance that anyone in Fingal, any place on the landscape, is to its nearest bus route. And here is the distance that anyone anywhere in Fingal would be to their nearest playground. So they're quite different rasters. And that is Euclidean distance.